Hi folks, I am Dr. Karen Goldberg and I work at the Department of Geology at Kansas State University. We may not realize that, but geology is all around us and it's part of our very daily lives. From the materials that we use, like the ice melt that we put in our roads during the winter and the cat litter in the box, to the fuel that powers our cars and the groundwater that comes up our wells. This is all about geology. I think geology is fascinating, and every time I go somewhere, I am always paying attention to some geological details or some interesting things that I can grasp from looking at the rocks and the formations around me. So I decided to share my passion with you by offering some information on the geological things that I encounter in my daily life. I am calling this Geonuggets, and I hope you'll find them interesting to learn about. So come on, join me in this adventure, and let's go together discover the incredible geology that might be right in front of you. So our first geonugget is right here in my own backyard. I live in Manhattan, Kansas, and all around town the buildings are made of limestone blocks. And this is also true for the entire state of Kansas. In this wall in my backyard, you can see stacked limestone blocks. Limestone is a rock composed of calcium carbonate or calcite, a mineral that we find forming coral reefs and shells in organisms like clams and snails. Carbonate sand particles accumulate in the ocean, get cemented together and harden as they get buried and compacted to form the limestone. If we look closer, we'll see that this limestone is fossiliferous, meaning it has bits and pieces of fossil. The kind of fossils that we can find in these limestones may vary. It could be some shells like brachipod shells or bivalves or bryozoans. But in this particular blocks in my backyard, what we find are crinoids. Now, crinoids are interesting animals. They are marine, are also called sea lilies because they live attached to the bottom by a stem. They have this a cup-shaped skeleton that is called the calyx with arms that the animal uses to capture food from the water. You can see here some of these bits and pieces that form the stem. On this part you can see a partially articulated stem, and you can see that this stems from the crinoids was formed by a bunch of disc-shaped plates, calcite plates that were stacked together. Here you can see the detail of one of these plates, and you can see something that is shaped almost like a flower, a tiny flower. It has 5 arms, and the reason for that is that these animals had a 5-fold symmetry like a sea star. So while the animal is living, the stem is in one piece and it's connected to the calyx and to the arms. The moment this animal dies, if there is waves or currents that are agitating this water, all these bits and pieces fall apart and they are scattered and they are broken. So this is what we see here in these rocks. Some of the plates, or they are called ossicles, they are still intact, they are not broken. Some others are broken, forming this sand-sized sediment that was lithified to form the limestone. When we look at these blocks then, we can say a number of things about the environment where these rocks were formed. First, we can say that this was formed in the ocean because crinoids are marine animals. And then we can also say that the water was relatively shallow because the crinoids are all disarticulated, they are broken up and they are separated from the original animal, which happens when there are waves or currents that are stirring up the bottom where this animal was living, making this animal fall apart. In deeper water, the waves don't hit the bottom, so this bottom is very quiet. And any animals that were living there upon their death, they are just laid to rest without being disassembled, like we see in the blocks here. Now you can see how shaking things have this effect of disorganizing and breaking thing. When you try to carry a stack of something, let's say candy like I have here, or it could be cookies, or it could be glasses, or whatever you want to stack up. If I carry this very slowly and I do not shake up much of my container, the stacks are going to continue together and organize. Now, if I were to shake up, and the moment I give it a little shake, the stacks are already falling apart, and the more I shake it in my container, let's say what waves will do to the bottom of the ocean, the more disorganized and scattered about my candies are. So this is basically what we can see from the organization or disorganization of the crinoid plates on the blocks in my wall. What we have here is a bunch of disarticulated crinoids of different sizes. Sometimes we find some of the stacks still attached, two plates here are still together. This one is separated. Here we have a little bit of another stem that is partially articulated there too. We can see isolated plates in some places and still some connected plates in others, but the long stems that form the crinoids are no longer existent, and we have some pieces that are broken everywhere. So this tells us that the agitation was so big as to disconnect the stems and break some of the ossicles. So now you see how a seemingly boring wall can suddenly become interesting once we have a story to tell about it. I hope you enjoyed the Geonuggets today, and I will see you next time. Bye.